Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover strength of materials in 6. The topic of this tutorial is electrical springs. Question 4. The question is included in the video. We have been asked to issue a cautionary note. When doing these questions, please use the method I am going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks even though your method and answer might be right. See the cautionary note at the beginning of the video. On a side note, please watch until the end of the video. If you watch the first 5 minutes, you will not gain a full understanding of what you need to do. There is no quick fix in strength of materials. It takes persistence, discipline and repetition. You have to use these steps in order to succeed. Let's get straight into it. Our question goes, 2 springs are parallel connected to carry a load. One spring has 16 coils with a 7mm wire diameter and a mean diameter of 38mm. The second spring has 19 coils and a 5mm wire diameter and a mean diameter of 42mm. The maximum shear stress in the spring must not exceed 360 megapascals, and the load is applied when the load is applied. And G is equal to 82 gigapascals. Let's put all this. Calculate the total stiffness of the springs, the maximum allowable load that can be applied, the stress in each spring, the deflection of the springs, and the strain energy in the springs. Okay, first things first is let's put our information onto the right hand side. Okay, first spring has, so N1 is 16 coils. The wire diameter, so small d, is 0,007, and the mean diameter, so that big D, is 0,038. The second spring has 19 coils, a 0,005mm, a 5mm diameter, and a mean diameter of 0,042. The shear stress is 340, 360 times 10 to the 6, and finally the GPA, the modulus of rigidity, is 82 times 10 to the 9. Okay, let's get to it. First is the stiffness, the total stiffness of the springs. Well, how we work this out is S1 is equal to G D4 over 8 D3 N. Okay, so now this works exactly the same for both. So G 82 times 10 to the 9 times 0,007 to the power 4 all over 8 times D 0,038 to the power 3 times 16. And this equals 28,031 kilonewton meters. Right, that's S1. S1, 28,031 kilonewton meters. Now for S2, all we have to do is take this away, and take that away. It's exactly the same, except this D is 5, that is 42, and this is 19. And that gives us, and this is changes to 2, so S2 is equal to 4,551 kilonewton meters. So S2 equals 4,551 kilonewton meters. Okay, now we add, so S total, we add S1 plus S2. So 28,031 plus 4,551, and that equals 32,582 kilonewton meters. Right. These will not be important anymore. Only the total stiffness will be important. So S total is 32,582 kilonewton meters. Next thing we do is the load on the springs. So what we will do is take the deflection. We will take the deflection of the springs. So deflection 1 is equal to deflection 2. And deflection is 8W1 d to the power 3 n over g d to the power 4. So 1 now over 8W2 d sub 3 d to the power 3 n g d to the power 4 sub 2. Okay, now we have everything that we need. So what we're going to do is this can go, that can go, this can go, that can go. Everything else is different. So we want W sub 1 by itself. So we have W2 d to the power 3 n times d to the power 4. This is all 1. That's 2. That's 2. Now over d to the 3 n to the 1 and d to the power 4. Alright. So let's put our values in. W1 equals W2 D2 is times 42 cubed times 19 times D1 which is times 7 to the power 4, D1 is 38 to the power 3 times N, which is 16, times D2, which is 5 to the power 4. W1 2 sub 2 sub 2 sub 1 sub 1. Now W1 equals 6,195 W2. Now this is important for later. W1 equals 6,195 W2. Right, that's important for later. Okay, next part. Now, W1, now this is the same question, still question 2. W1 is equal to pi D3 of 8D. Right, which equals, and tau. Right, so this equals tau 360 times 10 to the 6 pi times pi times D1, which is 0,007 cubed all over 8 times 0,038, and all this equals 1,276 kilonewton meters. No, kilonewtons, just straight kilonewtons. So W1 equals 1,276 kilonewtons. Now we need to do number 2. So this changes, and that changes, and nothing else changes. So we go for number 2, W2, W2. Right, this is 42, and this is 5. Number 2 is 133,929 newtons. 33,929 newtons. Now for the real W1, W1 equals, now we've got W2, so we've got 6,195 times 133,929, and that equals 829,69 newtons is W1. Okay, this is the one that you will use all the time because this is the lowest. As you saw, this was the highest. This is, you always use the lowest when you have compound springs. So W1, I'll say real, is 829,69 newtons. Alright, next question. We have answered this question, now the next one. Now question number 3. The stress in each one. So tau 1, because tau 2 is 360 megapascals. Now tau 1 is 8 W1 D1 over pi D1 to the power 3. So equals 8 times 829,69 times 0,00038 all over pi times d, which is 0,007 to the power 3. And this comes out at 234,07 megapascals. So the last one, the second to last question, is we do not need this towel. So the second to last question is the deflection. So deflection equals 8W1 D3 to the n over G D to the power 4. Yes. Okay, so deflection equals 8 times 829,69 times, now this is deflection, it's the only in spring 1 because the deflection is exactly the same. We can use any one of the springs. So we'll use number 1. So 0,038 to the power 3 times 16 all over G, which is 82 times 10 to the 9 times finally 0,007 to the power 4. And our deflection is 29,6 millimeters. So deflection now is important because we will need it. Okay. Now they want the total strain energy in the springs. So UT equals 0,5 W1 WT, sorry, and we will get T. So we will want the total strain energy, so we need U. So WT, we take W1 real and W2 real and we add them together. So what we will do is say 0,5 times bracket 133,929 plus 829,69 times 0,0296, and our final answer will be 14,262 joules. And that is the final sum. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you would like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.